For over 45 years, Voyager 1 has been traveling across space. Now the spacecraft has transmitted unsettling data to Earth, leaving experts perplexed. Some say it's broken, but for now we can't say for sure that the readings aren't indeed proof of a hitherto unknown elemental force in the universe. One of the world's most famous scientists, Michio Kaku, has now weighed in on the peculiar measurement results. Is it possible that we're dealing with some sort of unfamiliar force? What would be the repercussions for us? Is it possible that we are so close to discovering the equation that fully accounts for the universe? Listen up, because we're about to answer some really basic questions about physics. Welcome to Spaceverse, your portal to the wonders of the universe. Today, we're diving into an extraordinary discovery that's left the scientific community in awe. Voyager 1, the intrepid spacecraft that's been exploring the cosmos for over 4 decades, has just encountered something entirely unexpected in the depths of space. But before we dive into the details, hit that subscribe button and ring the notification bell so you never miss out on the latest space discoveries and updates. Alright, let's get started. For the first time, Michio Kaku discusses the groundbreaking finding. Japanese-American physicist Michio Kaku is to the United States what British physicist Stephen Hawking was to Europe. The now 73-year-old was born in California, and since his boyhood, physics and the cosmos have been the obsession of this man. Kaku studied theoretical physics, proposed theses, and authored dozens of bestsellers to help ordinary people better understand the cosmos and creation from the standpoint of physics. The man is renowned as a genius and a rising star in the field of physics. For the first time, he discussed the unsettling Voyager 1 probe measurement findings in an interview. And sure, it's possible we've made touch with some sort of alien power. But what about the possibility that this force is another piece of the puzzle necessary to bring together the major field theories? Perhaps, but there are still scientific communities that disagree. Kaku and several of his English-speaking peers refer to the unified field formula as the God equation. All cosmic phenomena and forces could be described by a single formula. You might be wondering what value such a formula could have. Well, this can be much more than you may expect, but we'll go into this in more detail later in the movie. The first step in solving this issue is for us to help you comprehend the magnitude of the Voyager 1 finding and the chasm between classical and quantum physics. Theoretical physics is the branch of science that provides explanations for the universe's largest phenomena. Planets, galaxies, acting forces, and laws for the dynamics and interdependence of these forces are all part of this picture. The physical works of Einstein's theories of relativity are the gold standards of this universe. Quantum mechanics, the other major branch of physics, emerged much later. Only because of our technological prowess are we able to explore the realms of subatomic particles. Quanta, quarks, and neutrinos are all examples of elementary particles that defy direct visual observation. Only in specially designed laboratories like Geneva's particle accelerator can their effects be observed and their presence studied. Think about how people who looked up at the sky with simple binoculars hundreds of years ago would never have been able to do this. A lot of what we know about physics comes from things that can be seen, measured, and proven through experiments. As an example, gravity is something we can't see but can feel and see its impacts. You can stand with both feet firmly on the ground, no matter if the earth is upside down or not. If you let go of an apple, it will fall to the ground. Isaac Newton, an English physicist, was the first person to say that physical forces are movements and processes. Then at the start of the 20th century, Albert Einstein was the first person to study photons and quanta, which are tiny particles. Most people think Einstein won the Nobel Prize for the theory of relativity, but he actually won it for this. He knew his whole life that his finds were important, but they were not nearly enough to explain everything in the universe. All his life, he looked for what he called a unified field theory, which was a science formula that could explain everything from matter to electricity. Einstein failed, though. The smart person never believed in quantum physics. His famous quote, "God does not play dice," refers to the fact that chance seems to rule after a certain point in the subatomic world. The scientist didn't see this as making sense. Born in 1947, Michio Kaku's academic pursuits introduced him to quantum theories for the first time. Kaku, who also pursued a career in classical theoretical physics, realized early on that quantum and classical physics were not mutually exclusive. For Kaku, the symphony of one-dimensional strings in string theory provided the missing link between the two fields. The central tenet of string theory is that there are no ephemeral quanta or even smaller particles that are both particles and informed waves. Instead, everything in the universe can be thought of as a string or thread that only has one dimension. These, which oscillate at various rates, make up the primordial web of the cosmos. Particles or forces emerge at various frequencies. Collectively, the forces of the universe would vibrate and sound like a beautiful symphony. The idea has a flaw, however, in that it assumes the existence of at least 6 additional dimensions. This very situation is a source of stress for many traditional scientists. Physicists would have to accept the presence and probability of other invisible worlds within our known universe, as well as the existence of forces and possibly forms of matter to which we do not have access if they were to accept the existence of 6 additional dimensions beyond the 4 we are now capable of describing. While Einstein disagreed with quantum physics' emphasis on chance and the imprecision of its measurements, he did agree that there are almost certainly many more dimensions than spacetime. In addition to Einstein, the German physicist Burkhard provided a striking illustration of how the universe suddenly makes sense. Most of the previously unresolved mathematical formulas may be traced back to his hypothesis of 12 dimensions. However, the existence of these other dimensions inevitably brought even more uncomfortable concerns, which is why many scientists reject these concepts outright. So how does this relate to Voyager 1? Perhaps you are wondering what a technologically relic of the 1970s probe could possibly have to do with finding the answer to the field or God equation. It's not hard to figure out, however, there are several schools of thought when looking at the current probe measurement data. However, you must make up your own mind as to what is true and feasible. We're about to show you the evidence. Both Voyager 1 and Voyager 2 set out for the solar system's outer planets in 1977. They were only a few weeks apart, and their constellation was unlike any other in the sky, so it was like taking a fast route. Therefore, NASA's research facilities hurriedly assembled 2 basic but working probes. Now, 46 years later, both probes are still in orbit long after their primary missions have concluded gathering information from parts of the galaxy that have never previously been explored. The first artificial object, Voyager 1, left the solar system in 2012. Our sun's constant stream of particles envelops the star and all the planets around it like a gigantic bubble. The intensity of our sun's plasma streams gradually decreases over time. Scientists then observe a region they call the heliopause. The next step into the vastness of the cosmos is the interstellar medium, sometimes known as the space between the stars. The forces at play, and more specifically the particle density, differentiate the 2 zones. About 100 particles per cubic centimeter can be found within the solar bubble, but just 1 particle can be found in interstellar space. This is why most scientists now believe that interstellar sound transmission is either impossible or extremely weak. Particle oscillations transmit sound, hence in the absence of particles, there should be no transmission of oscillations. Since no one or thing had ever traveled thus far into space before, scientists had no way of knowing for sure. Mathematical and physical assumptions as well as measurements of very faint oscillations that we can get from space, such as gravitational waves, had been the only sources of information regarding interstellar space until recently. Now we were all shocked when Voyager 1 crossed over into the interstellar medium. The density and stability of this turned out to be more than expected. Scientists predicted that the heliosphere will grow in size as a result of the high solar winds detected around the time Voyager 2 crossed the border. The fact that Voyager 2 transmitted the same information as Voyager 1 did 6 years earlier came as a complete surprise. Because of this, previously held beliefs regarding the nature of interactions between the interstellar medium and the heliosphere have been revised. A pressure impact of interstellar space on the heliosphere was responsible for the extremely high and stable particle density. Voyager 1 has now been in orbit for over 30 years, traveling at a speed of approximately 37,000 miles per hour. And much to the surprise of scientists, the probe still successfully transmits data. Despite the fact that it now takes these more than 20 hours to reach Earth, they are collected solidly and dependably by the antennas set up for this purpose. Given that both the density of particles and the ability to transmit radio waves in interstellar space are steadily decreasing, one is left to ask how this is even possible. The Voyager probe may have the answer if it makes another shocking discovery. Researchers feared the Voyager 1 probe was broken after it suddenly reported so much unsettling data in 2022. Telemetry data showed that the probe had entirely lost its bearings, therefore a hastily enacted technical rescue plan was put into action. Data quieted down shortly thereafter, and the views of some scientists persisted. Voyager experienced a minor malfunction due to its advanced age. Other scientists, however, find a new and intriguing perspective in these measurement data. Specifically, they are looking into the possibility that an undiscovered force was responsible for the turbulence. Perhaps this is a type of elementary force that hasn't been fully investigated yet. The possibility of extraterrestrial intelligences being behind the unknown force with which Voyager 1 made contact was even raised by some. Voyager may first possibly encounter whole new forces in interstellar space, as suggested by Michio Kaku, who has warned against drawing hasty conclusions based on the results. But he did say that further study is needed from scientists before we can be certain. Is this power the final piece of the divine jigsaw? If this is the case, we may be getting closer to understanding the origins of the universe and life on Earth. But now that we have the God equation, what should we do as humans? The response to this inquiry is both straightforward and incredibly satisfying. If we had such an equation, not only could we comprehend the creative process, but we could actively influence it as well. Russian astronomer Nikolai Kardashev developed a scale in the 1960s to measure the progress of civilizations in terms of their energy production and scientific prowess. A super civilization at the other extreme of the spectrum would be able to create energy out of thin air and actively shape creation by reshaping the cosmos or perhaps making entirely new universes and dimensions. As we wrap up our journey today, a big thank you for joining us at Spaceverse. Your support fuels our cosmic exploration. Don't forget to subscribe and hit the notification bell to keep exploring with us. Until our next cosmic encounter, see you.